how you could, you're going to develop an understanding of this curve that will help you with the TI. It's almost like swinging with two bats before you then swing with one. Swing super fast, super hard, aim for the fence. How could we have gotten roughly 16%? Based on what we know already on the board, how could we have gotten that 16%? What do you think? Give me some ideas. Give me some ideas. Let me straighten it up a little bit here. What do you think? What do you think? Jordan, go ahead. Use your thing from your idea from before.
If you're going all the way over, it's accumulated, give me 100, so you subtract 68 again.
Where'd the 68 come from, friend?
68 is the middle part, so you know it's going to be even on both sides, and then that equals 32, you take 32 and divide by 2.
See, what Jordan's hitting right now is symmetry and the fact that all the area under the curve is 100%. That has to be. That's the correlation. That's the equivalence, if you will, between the sum of the probabilities in a discrete random variable summing to 100% and the sum of the probabilities in this curve equaling 100%. It's just that there are infinitely many probabilities on this curve. Every vertical line is probability. So, if I shaded the entire curve left to right, and as Jada just proved to me, I can't do that. But if I did, it would be 100%, right? Arguably, it's 100% if you go out far enough. I know that 68% of them are between -1 and 1. That means the other 32% are out here. Does that make sense? So from -1 and down is from -1 down and from -1 or from +1 up is 32%. Which means just this part of it has to be the 16, which is roughly half of 32. That's all we're saying. That's all we're saying. And that's the idea. So we've got symmetry of the curve and the sum summing to 100.
So from 2 to 1, or -2 to -1, that's like 8 or what?
Well, good, very nice. Now, Jada, one thing you don't want to impose on this curve is linearity. And here's the deal. Everybody do this. Everybody do this. We already did -2 to -1, correct? We did -2 to -1, and we got, I believe it was about, was it 13.5%, something like that? -2. Everybody do -1 to 0. Do -1 to 0. This is again a between problem, okay? And Jada, this is a fantastic question, by the way. Go, do -1 to 0 between -1 and 0. Now remember, this area here was about 13.5%. This is 34%. Notice it's the same distance on the horizontal axis, but there's vastly more area. It has to be, because the curve is not linear. If it were a linear functioning function, as you moved over, does that make, see, and that it's hard not to think of it that way, because you want it to be, oh, well, if it's the same here, it should change the same way here in a linear way. But it's not, it's an exponential function at the heart of it. Does that make sense? It's a great question. Thank you for asking. And it always comes up at some point. Thank you for bringing it up so early. It's perfect. So just so you know, and we couldn't we have figured out that it was 34% without even running the TI? This whole thing is 68. So that's got to be half of that. Exactly. Cool? Fair enough? Good. Let's do a right shading problem forwards to make sure that we know what that's going to look and or act like. And just so you know, you don't always have to do them so they don't cross 0. You can also have them cross 0. Let's just make up a superfluous, kind of silly example. Let's go from -2.1, yeah, why not, and shade all the way into that tail. Now here's one you can't do right now without using the machine. Because I never talked about what 2.1 standard deviations, how far out that is, or how much area that picks up. We've done 1, we've done 2, we've done 3. And this goes back to Jada's point, a very good question. Again, like I said, we can't just say, okay, to go from 2 to 3, 2.1 is 1/10 of the way. Well, it is horizontally, but not vertically. So we actually have to use the machine to answer this one. There's no way around it, unfortunately. Well, actually, not unfortunately. Fortunately, we have the machine. So, we're going to grab it. More probs. It's still forward. Why is it still forward, friends? Because you still have the z-score. So we're going to shade to the right. We're going to shade to the right. We're going to start at -2.1. And it's going to draw it for you. Shade it, start a little bit over there. You're going to pick up quite a bit of the curve, roughly 98% of it. Roughly 98% of it. There you go. Cool-ish? Cool-ish. You're probably thinking like, okay, this is fine. I'm not going to push buttons. I don't know what it means yet. That's fine. I totally get that. That's part of processes. Once you know how to push the buttons and work the mechanics of this, then we put the context to it. And just a heads up, the reason I gave you this is because for years, let me just show you this real quick. For years, people have been using, let's back up here. Where is it? Where is it? Hang on. There they are. And this one too, don't forget this one. There's two of them. This is what your TI is doing for you. It's using these tables for you. So for example, if you needed to figure out what the area was from -2 to 2, you'd first have to go in here to -2. Let's see, -2.00 here, this one here, and then we're shading to the left. So -2 has an area of 2.28%. That's the tail area.
Wait, why is it 0?
Don't worry about this. You're not going to have to use this.
Okay.
And then you're going to have to realize that that's also the 2.28% over here. So together that's 4.56%. So you take 4.56% away from 100, that leaves 95.44% in between, which is what the TI was telling us without having to go through all this crap. So basically, this is the way traditionally you've learned how to use Z-scores. Nothing kills excitement about this course quicker than, I mean, did you see how far I had to scroll down to find this? This is the way traditional stat courses are taught, by using pages of crap like this. No, that goes away. That goes away with technology. How many formulas have we done in this class? 2, I think. There'll be one more, maybe today. But the one for today is crucial, and we need it. We need it to go back and forth between the standard and the general normal distributions. But those 3 are it. That's it. There are no more after you get through those. And everything else is just, like I said, sleep-inducing. But speaking of sleep-inducing, you're getting that glazed look. Let's take 5. Yes, let's take 5. We'll come back and do some backwards problems and then see why the hell we care. Because I'm not sure you're convinced yet. And that's okay. You shouldn't be convinced yet. It's not all obvious why you should care right now. Good. Pause up the camera.
You wanted to